Good evening. Today we're going to look at lesson 7.2, which is operations with linear functions. Operations, when I say operations, I'm talking about the four basic mathematical operations such as addition, subtraction, multiplication. But we're not going to do division with linear functions. We're going to perform these three operations. So we have done this before. It's called simplifying an expression, but only thing they have given it as a function now. So how to do this? What do they mean by operations with linear functions? So when I have a function, I'm given two functions, f of x equal to 2x plus 9. This is a linear function. You see that y equal to mx plus b, a linear function. I'm given another function g of x equal to 6x minus 1. So I'm given these two linear functions. Because it's of the form y equal to mx plus b, it is a linear function. So now I want to perform different operations on that. I want to find a third function. Find a third function, which is h of x, which I get by adding these two functions, f of x plus g of x. So I'm adding these two functions. When I add these two functions, I get a third function which can be represented by h of x. So basically what I'm doing is I'm taking these two functions and I'm adding them together. So f of x is 2x plus 9. I will always replace using a parenthesis. So in case if I have a negative sign or something, it will be taken care of. So in this case, I'm adding these two. This is 6x minus 1. So I have my f of x, I have my g of x, and I'm adding these two guys. So I have my parentheses. You have seen these expressions before. I want to simplify this expression now. So first remove parentheses. There is nothing up front for me to distribute. So I'm just removing the parentheses. 2x plus 9. And this is a positive sign. If I distribute that, nothing changes. So I'm just going to write this is plus 6x minus 1. Now I have an expression that I want to simplify again. Now I'm going to combine like terms. 2x plus 6x is 8x and 9 minus 1 is 8. So it's 8x minus 8. So my h of x is 8x minus 8, which I got by adding these two functions. So I performed the addition operation with my linear functions. So you guys know this. It's just the old wine in a new bottle. So you're just getting a new thing. Alright. The next again, now we performed addition. We're going to perform subtraction. Now I'm going to find another function, k of x. Okay. Keep naming these things, right? So I want to find k of x, which I get by subtracting these two functions now. I'm having the same functions, f of x equal to 2x plus 9, g of x equal to 6x minus 1. Now I'm going to use the same thing, but this time I'm finding a new function, k of x, which I get by subtracting f of x and g of x. So I'm subtracting these two functions now. So we know that f of x is 2x plus 9 and g of x is 6x minus 1. You guys must have written it down in your notes already, so you don't have to go back and forth. So f of x is 2x plus 9. Again, I'm using a parenthesis to plug in my value for f of x. Minus g of x is 6x minus 1. So here is where you will appreciate the usage of your parentheses, because now I have a negative sign outside. So it's going to make a lot of difference if you have the parentheses. Okay, so whenever you're replacing something, substituting something for a value, you need to use a parenthesis. This we saw when we evaluated our expressions before. So here, there is nothing up front. So I want to remove my parentheses now. I'm going to simplify this expression. Remove the parentheses. There is nothing up front for me to distribute. So I'm going to just write it as is. Now when I come to this expression, there is a negative sign that's sitting up front. So I have to distribute that negative sign to both of them. I have to distribute the negative sign. So in case if you are confused, you can write that is a -1 there. So I'm distributing a -1. So -1 times 6x will give you a -6x. -1 times -1 is going to give you a +1. So now I've removed my parentheses. I'm going to combine like terms. So my like terms are 2x and -6x. So 2x minus 6x will give you a -4x. And 9 and 1, +9 and +1, together I will have a +10. So I got my new function k of x, which I get by subtracting the f of x and g of x, which will give me 4x, -4x plus 10. So that's my new function k of x. So we performed addition and we performed subtraction of two given linear functions. This is simple stuff. We have done this before, but it's just a new name. Alright. Okay. Now we're going to perform multiplication. Multiplication with two given functions. Alright. So now I have a function f of x, which is 3. Is this a linear function? Y equal to 3. What kind of a line am I going to get for y equal to 3? It's a horizontal line, right? Y equal to 3 is a horizontal line, and yes, it is a linear function. So I have this function f of x equal to 3, and I have another function g of x equal to 7x plus 1. So f of x equal to 3 and g of x equal to 7x plus 1. Now I want to find another function j of x, which I get by multiplying f of x times g of x. This also we have done before, only thing you know it in a different name. So I'm multiplying these two functions, f of x times g of x. I know f of x is 3 times my g of x is, parentheses, my g of x is 7x plus 1. So 7x plus 1. So it is 3 times 7x plus 1. So there is no point in putting the parentheses for just one number. So I'm going to say it is 3 times 7x plus 1. Does it resemble something that we did before? Of course, this is your distributive property. So what I'm going to do is distribute the 3 to both of these guys that are inside my parentheses. So 3 times 7x is going to give you 21x. 3 times 1 is going to give you a 3. So that's both are positive, so they stay positive. So 21x plus 3 is my new function j of x, which I got by multiplying my f of x and g of x. So these are the 3 basic operations that we do with my function. There will be some word problems, yes, but we will do it in class. Alright. So these are the basic things that I want you to know before we come to class tomorrow. Alright.